Hello everyone. இப்போ நம்ம இன்னைக்கு பார்க்க போகிற டாபிக் என்னன்னு பார்த்தீங்கன்னா the Maxwell's equation in free space அதோட சொல்யூஷன்ஸ். ஓகே, ஸோ அதை பற்றி கொஞ்சம் எக்ஸ்ட்ரா நம்ம தெரிஞ்சுக்கலாம். ஸோ Maxwell's equations in free space. ஸோ என்னென்ன ஈக்குவேஷன்ஸ் நம்ம எழுதணும்? divergence of E vector is equal to 0, divergence of B vector is equal to 0, curl of E vector is equal to minus partial B vector divided by partial T, curl of B vector is equal to mu naught epsilon 0 partial E vector by partial T, right? இப்போ இது நம்ம வேவ் ஈக்குவேஷனாக நம்ம எழுதணும். எப்படி எழுதணும்? இந்த லாஸ்ட் கிளாஸ்லேயே பார்த்தோம் இதை. ஸோ ஃபஸ்ட் இந்த ஈக்குவேஷன் நம்ம நேம் வச்சுக்கலாம். ஈக்குவேஷன் நம்பர் 1, ஈக்குவேஷன் நம்பர் 2, ஈக்குவேஷன் நம்பர் 3, ஈக்குவேஷன் நம்பர் 4. ஈக்குவேஷன் 3 அதை வந்து கேர்ள் எடுத்துன்னு வச்சுக்கோங்களேன். ஸோ லெட் அஸ் டேக் கேர்ள் ஆஃப் ஈக்குவேஷன் நம்பர் 3, கேர்ள் ஆஃப் ஈக்குவேஷன் நம்பர் 3 என்ன கொடுத்தது? ஸோ அது மூலமாக நம்ம என்ன பண்ணோம்? del square E vector is equal to mu naught epsilon 0 partial derivative square with respect to time square E vector. இது நம்மளுக்கு தெரியும். இது வந்து ஐடென்டிஃபை பண்ணிட்டோம். This is 1 by c square. So this implies del square E vector which is equal to 1 by c square partial square E vector by partial t square. This is wave equation. Similarly, curl of equation number 4 which we last class derive pannom, magnetic field also obey wave equations. Okay, so these are the wave equations. Electric field obey wave equations, magnetic field also obey wave equations. So now differential equations, the wave equations are differential equations. So electric field or wave equation I will write down once again, 1 by c square partial square E vector divided by partial t square nebula operator square B vector 1 by c square partial square B vector divided by partial t square. That's it. Whose solutions? These are the differential equations. Partial differential equation. Okay, now we can write down the solution. The simplest solution for the wave equation is the plane wave solution. So what is that? Plane wave solutions. Okay, now what is that plane wave solution? The E vector, E vector of r comma t, I can express as some E naught vector. It's a constant vector, and so this is an amplitude and this is a phase. E power I k vector dot r minus omega t. This is for the electric field. இதே மாதிரி நம்ம என்ன பண்ணலாம், magnetic field we can write down B of r comma t is equal to B vector B naught vector e power I k vector dot r minus omega t, where E naught and B naught, so these two factors, they are nothing but amplitude. Okay, so that means what, they are complex number. In general they in the complex number are. So E naught and B naught are in general complex amplitude. Complex amplitudes. So they are constant in space and time. So they are constant in space and time. Okay. Now this factor, the e power something இருக்குல்ல, இந்த factor வேற ஒண்ணும் கிடையாது. They are the phase. It contains phase. Okay. இதில் k vector இருக்கு பாருங்க. So the k vector gives you the direction of propagation of waves. So k vector என்றது என்னது? So what is this k vector? That gives you the directions of propagation of the wave. Okay, so அதனால இதுக்கு பேர் வந்து இந்த k வெக்டருக்கு வந்து actually it's nothing but what, it's a wave vector. Another name for this is called wave vector. Okay, so that gives you the direction of propagation of wave, the propagation vector அப்படினு சொல்லுவோம். Okay, now I can write down this k vector as k times some unit vector. What is this k? The magnitude of this k vector times unit vector, and this is called wave number. So this one is called wave number. Okay, now this k n hat, now this k can be written as 2 pi by lambda n hat, where k can be written as 2 pi by lambda. Wave number can be written as 2 pi by lambda. இதை நம்ம என்ன பண்ணலாம்னா in terms of frequency and frequency எழுதலாம். wave length frequency எழுதணும்னா என்னது? See, velocity is equal to c is equal to nu lambda. So lambda is equal to c by nu. Okay, so I can substitute this. So 2 pi by c nu n hat. Okay, now what is 2 pi nu? 2 pi nu அப்படின்றது வேற ஒன்றும் இல்லை, angular frequency. So k vector now can be written as, this is equal to omega by c n hat. Now what is this n hat? n hat என்றது வேற ஒன்றும் கிடையாது, it's a unit vector along the direction of propagation. Direction of propagation. Okay, so we can further calculate that the relative directions of electric field, magnetic field and R. எப்படி கண்டுபிடிக்கணும் பார்க்கலாம். So let us calculate the relative directions of electric field, magnetic field and the propagation vector k vector. So let us calculate this. We know from the equation 1, that is from the Gauss's law. So this is the Gauss's law in electrostatics. Okay, for the electric field, E vector dot divergence of E vector is equal to 0. Now what is this divergence of E vector? E vector is already known to you. E vector is equal to some E naught vector e power I k vector dot r minus, sorry, here the minus comes here, or minus omega t. When I take the divergence of E vector, the divergence is an operator. There will be an operator partial. So either the Cartesian coordinate. So this becomes, in Cartesian coordinate, it is simply partial derivative with respect to x I hat, partial derivative with respect to y j hat, partial derivative with respect to z k hat. Okay, now dot product with E vector. Now what is this E vector? E naught, correct, e power I kx x plus ky y plus kz z, because there is a k vector dot r vector here. The dot product minus omega t, the bracket. So this bracket is this bracket. Maybe I will put a bracket like this, so it is understood. Okay. Now, if I x derivative, when I take partial derivative with respect to x, so this is constant in space and time. So this derivative. So in that derivative exponential derivative same factor I will get. So x derivative x, the coefficient I k x கிடைக்கும். So I k x I hat known. Okay, this I in the I k x I hat. So first is the derivative. Similarly, when I do this derivative for y, so I will get I k y j கிடைக்கும், I k z k hat கிடைக்கும். மூணாவது இதுக்கு டெரிவேட்டிவ் எடுக்கும்போது. So this is simply, when I pull I outside, simply kxi plus kyj plus kz k, and it is simply I k vector. So ஒரு ட்ரிக்கா நான் வச்சுக்கோங்க. Okay, now what is the trick? When del operates on either divergence or curl, or doesn't matter, so del is replaced by ik vector அப்படின்னு நான் வச்சுக்கோங்க. So இது மறந்துடாதீங்க. Okay, so del, wherever you put del, when it acts on this either magnetic field or electric field, del இருக்கிற இடத்துல வந்து ik vectorன்னு நம்ம போட்டுக்கலாம். ஸோ இது சம்திங் லைக் இன்னும் ஃபூரியர் ஸ்பேஸ்க்கு ட்ரான்ஸ்ஃபார்ம் பண்ணுற மாதிரி இதை பற்றிலாம் ஃபர்தராக நம்ம வீடியோஸில் பின்னாடி நம்ம பார்க்கலாம் டீட்டெயிலாக. ஓகே, let me go further in this calculations. Okay, so what is divergence of E vector then? That is equal to 0 from the Gauss's law. So del is nothing but what? This operator, nebula operator. Okay, this is written as ik vector dot E vector, that is equal to 0. So which means k vector dot E vector is equal to 0. Since I is not equal to 0, so the coefficient whatever here, that has to be 0. Therefore k vector dot E vector is equal to 0. So this implies this k vector and E vector. So when two vectors are dot products are 0, then these two vectors are mutually perpendicular to each other. So therefore they are perpendicular to each other. So this is first observation from the Gauss's law, equation number 1, that is Gauss's law. Similarly, from the second equation, del dot b vector is equal to 0. So del is replaced now as ik vector dot b vector is equal to 0. So k vector dot b vector is equal to 0. So this implies k vector and b vector are perpendicular to each other. So you put r here, okay, are perpendicular to each other. Okay. Now what is that? So k is perpendicular to e vector and k is perpendicular to b vector. Now what about e and b? Is these e and b are parallel or perpendicular? Okay, so that we have to see. See, when I do the cross product, that is the third equation. From the third equation, so take third equation, Maxwell's equation, that is del cross e vector is equal to minus partial derivative of b vector with respect to t, right? Now what is this del? That is nebula operator. So this is called nebula operator. Nebula operator, and this is a nebula. Actually, when I put hat, it is called nebula operator. It is sometimes we'll call it as a del. Loosely we can call it as a del. Okay, and this operator in this case, okay, in this problem, what we have done, we write in terms of Fourier space. See the operator பார்த்தீங்க நம்ம ஒரு ட்ரிக்காக எழுதியிருக்கோம் பாருங்க, டெல்ல வந்து ஐகேன்னு போட்டிருக்கோம். அதுக்கு இந்த ரீசன் நான் சொல்லியிருக்கேன், பட் இதை பற்றி டீட்டெயிலாக இன்னொரு லெக்சரில் நம்ம பார்ப்போம். ஓகே, ஸோ டெல் கிராஸ் இ இது என்ன பார்த்தீங்கன்னா ஐ கே வெக்டர் கிராஸ் இன்னு எழுதிக்கலாம், மைனஸ் சி இந்த ஈக்குவேஷன் மேக்னெட்டிக் ஃபீல்டு இருக்குல்ல, மேக்னெட்டிக் ஃபீல்டில் நான் டைம் டெரிவேட்டிவ் எடுத்தேன்னா what I will get? So when I write magnetic field here, b naught e power I k vector dot r minus omega t, when I take the time derivative, b naught அப்படியே வந்துடும். இந்த இடத்துல ஃபர்ஸ்ட் பார்ட் ஒன்றும் ஆகாது, இங்கே தான் டைம் பார்ட் இருக்கு. So you will get a minus I omega e power I k vector dot r minus omega t. So whenever I do the time derivative, I will get minus I omega, then b vector I will get. Okay, so இது என்ன ஆகும் அப்படின்னு பார்த்தீங்கன்னா minus I omega b vector. So in the I gets cancelled, so this I and this I gets cancelled. K vector dot E vector is equal to omega B vector. So which means B and E are not parallel. Okay, so they, because the cross, since K and E are perpendicular to each other, when I take the cross product எடுக்கும்போது என்ன ஆகும், the resultant vector will be perpendicular to the plane containing the vectors like k and e here, right? Or a and b vectors are perpendicular அப்படின்னும்போது a b அந்த பிளேனுக்கு perpendicular vector தான் resultant vector கிடைக்கும், அந்த direction தான் கிடைக்கும், கரெக்ட்டுங்களா? So in the same manner k vector and e vector are perpendicular to each other ன்ற நம்ம ஆல்ரெடி பார்த்துட்டோம். ஓகே, ஸோ therefore இதில் கிராஸ் ப்ராடக்ட் எடுக்கும்போது 0 கிடையாது. ஸோ என்ன கிடைக்குதுங்க, இட் இஸ் அலாங் பி வெக்டர். ஸோ அப்போ என்ன ஆகும்னா பி வெக்டர் அப்படின்னும்போது the b is perpendicular to both k as well as e vector. That's the conclusion. So what is that? So which means b is perpendicular to both k vector and e vector. right? So this is a very important note which we noticed here. The same manner, இதே மாதிரி நம்ம என்ன பண்ணலாம்னா, we can also calculate from the equation number 4. Equation number 4 என்னதுங்க? So equation number 4 Gauss's law, Maxwell's equation del cross B. So that part also we will take. So del, that is nebula operator, right? Del cross B vector is equal to mu naught epsilon 0 partial E vector by partial T. இது என்ன ஆகும்? So ik cross B vector which is equal to mu naught epsilon 0. So del, see when I here I said a trick, right? This is the trick. When I take the partial derivative with respect to time here, okay, so I will have to put minus I omega, right? So partial derivative with respect to time replaced by minus I omega. Okay, so when I do that, minus I omega and this is E vector. So once again I gets cancelled and K vector cross B vector is equal to, so mu naught epsilon 0 omega E vector. So the same observation. So E is now perpendicular to both K vector and B vector. So this is another important thing. Okay, so இப்போ என்ன ஆகுது அப்படின்னு பார்த்தீங்கன்னா, okay, so now let me conclude this. So this means B vector, E vector and K vector are mutually perpendicular to each other. Okay, mutually perpendicular to each other, correct? And further, B vector and E vector, correct, are perpendicular and also they are both that is E and B, right? So what is K? K is the direction of propagation, right? K is the direction of propagation, and B and E are perpendicular to each other, and they are perpendicular to K, that is direction of propagation. Since we know that E and B satisfy the wave equation and therefore they are electromagnetic waves, right? So they are propagating in particular direction, they are at least perpendicular to both E and E. அதனால இது என்னதுங்க, the electromagnetic waves are transverse in nature. So they are transverse waves. They are transverse waves. So this is very, very key point. So so transverse waves nala enna aguduna, so it doesn't need any medium for that propagation. So that is, so which means therefore it's a key point. It needs no medium for the propagation. Okay, whereas sound waves is longitudinal waves, it needs medium for the propagations. So it is totally a different thing. Okay, so I will stop here. Thanks for watching this video.